Hi, everyone. Thank you so much for showing up. I'm Kelly. I work on research at Chroma. We're an open source vector database company building Retrieval for AI. And a while ago, we published some work on generative benchmarking, which is essentially a way to build custom eval sets from your own data. And yeah, I guess I'll just get right into it then. So I'm sure a lot of people coming into this are at least familiar with what evals are and why they're important. You need evals if you want to systematically debug your AI systems. And for retrieval specifically, it might look something like this, where you have this task where you're given a corpus of documents, you have a set of queries, and you also have query document pairs. So you would take an embedding model, you would embed that corpus of documents, and then for each query, you would embed that, retrieve the top K documents. And if you retrieve a matching document in the top K results, then that means you have a success. So that's how you get metrics such as like recall at K. And a very popular benchmark for this in retrieval is MTEB. It's also referred to as the massive text embedding benchmark, but you've probably seen this come up a lot. If you see like the release of any new embedding model, it's probably in like the first few lines of the release. For example, this was Gemini's recent embedding model release where they talk about how they achieved top rank on MTEB multilingual. And this was for Juno's release. They said they outperformed OpenAI and Cohere on MTEB. So MTEB is very popular and is widely used because it gives people a very easy and convenient way to compare like embedding performance through a unified metric. But when you think about evaluations, you really have to think about like what kind of data you're working with and really think about like what you're actually measuring as well and whether that's actually useful. So when you think about those questions, there are some limitations that come up with MTEP. The first one being that the data itself is pretty generic. So for example, one of the data sets is a Wikipedia data set. So you might have like a question document pairing like this. And the entire data set itself is pretty general. And even if you're working with domain-specific MTEP datasets, like there's legal domain datasets, might contain like a corpus of legal documents, but it still doesn't get as specific as the kind of data that you're probably working with in your retrieval application. The second point is that the data is artificially clean. By this, we mean that the query document pairs are very polished. So you have this question here, and the matching document is essentially like a perfect response to that question. But in the real world, you're often going to have queries where the user queries are a lot more ambiguous, and it's not going to fully match the document. The questions are also likely to come up as more of like statements rather than complete questions like this. And lastly, there's also risk of data contamination. So because a lot of these data sets, they're all like public data sets, there's a pretty good chance that the embedding models you're evaluating have seen this data before. So it becomes pretty hard to differentiate whether you're testing for like true retrieval or if the models just memorized that benchmark before. So I guess to summarize all of this about MTEB, if you have really good performance on a public benchmark for a given embedding model, that doesn't necessarily guarantee that you'll also get that good performance for your specific production pipeline. So that's why we started working on generative benchmarking. As I mentioned before, it's a way to generate a custom eval set, which basically consists of a set of queries. And because we generated queries from those documents, we end up with query document matches, all generated from your data. So it addresses the limitations that I talked about previously, because this eval set is generated from your data. It's as specific as you can get. The queries themselves are also more realistic. We generate them in a way that they're maybe like more ambiguous to reflect real user queries that you might see in production. And lastly, if you're working with your own private data, you also know that the data hasn't been seen by these embedding models before. So you're actually testing for retrieval and not memorization. So generative benchmarking is pretty useful if you're building a retrieval application because it can help you select the best embedding model to use for your data. And it can also help you iterate on components of your retrieval pipeline as well. For example, you can experiment with adding a re-ranking step. You can experiment with chunk rewriting as well. Because you can generate a custom eval, every time you make this kind of change, you can see how your like quantified metrics like change as your retrieval system changes, which is very useful because it's not something you can currently do with MTEP. MTEP is literally just a static benchmark. The score doesn't change for a given embedding model. But if you have a generative benchmark, you're able to, see how your performance changes as you change your retrieval system. So I'll go through this entire process of generative benchmarking through a case study on weights and biases. We partnered with them for this technical report, specifically using their technical support bot. So the bot would basically work in this kind of fashion where you have a user query, like how can I view my previous runs? And the bot would retrieve the relevant chunks of documentation. And then using those relevant chunks, it would generate a response. So it's just basic RAG. And for this case study, we used our document corpus, which contained around 13,000 chunks and around 2,000 real user queries from production. And we use those real user queries because you kind of use them as a proxy for how representative our generated queries are. So I'll get more into that, more into like how we did that analysis later on. But we got some pretty interesting insights from this. The first one was that the original embedding model that they used actually performed worse out of the four that we tested. We also saw a contradiction with the MTEB model rankings. So kind of showing that you really need to evaluate on your own data and not just generalize from these MTEB scores. And lastly, we identified a pretty good portion of document chunks that were judged as irrelevant. And I'll get more into what that means later on. But yeah, the overall generative benchmarking process can be broken down into these two steps. First, you have chunk filtering. So this process basically, filters for chunks that are good to generate queries from, filters for topics that users will actually ask about. And then from that subset of filtered chunks, we're going to generate our queries to end up with an eval set of queries. So the first step is chunk filtering. And yeah, as I just mentioned, the purpose of this is to identify the document chunks that users would realistically query. This was an example of a document that was filtered out for weights and biases. It's about the startup raising $3 million. It's pretty unlikely that a user using their support bot would ask about this. They probably want to get help with like debugging or just ask about their technical documentation. They're probably not going to ask about anything related to startup news. So we would want to filter out these kinds of documents so that we generate queries from, topics that are actually relevant to the user, so we can get more of a representative eval set. And we do this chunk filtering using an LLM judge. But more specifically, we use an aligned LLM judge, which basically means that we have a set of human labeled data, and then we iterate on our LLM judge to make it more aligned to that. And we do this using a framework called EvalGen, where we basically have a set of LLM judge criteria, like the ones to the right here. And then we also have a small subset of human labeled data. So these are like document chunks that were labeled as like good or like bad document chunks by humans. And so we run our LLM judge, see how it compares to our human labeled data. And then we keep iterating on each prompts, maybe switch out like a few criteria and see how our alignment score changes. So once we got a pretty good alignment score, we use that to filter out the rest of our document chunks. So we initially went from our set of around 13,000 document chunks to around 8,500. And so now that we have our filtered out document chunks, we move on to query generation. And we're going to do this by using user-provided context and example queries. So the LLM prompt might look something like this, where you give it, the context of the kind of retrieval application you're building. You give it the document chunk, and then you also give it some example queries as well. And these two are pretty important components because providing the context basically helps to get the LLM to focus on the kinds of topics that users would ask about, and example queries help with the style of query to generate. And so if you were to naively generate a query, which basically means that you would generate a query by literally just giving it the document chunk and telling it to generate a query without giving it any context or example queries, it might generate something like this, asking like, what is the purpose of artifact versioning in weights and biases? Whereas if you give it the context that this is a technical support bot and talk about what weights and biases does and give it some example queries, you might get a query that's more realistic, like artifact versioning not working. So yeah, these I guess like user provided like components are pretty critical for generating realistic queries that are maybe more like ambiguous and reflect practical scenarios. So now that we have our eval set of queries, we also have our query document pairs. Our query document pairs are basically formed by like the document that we generated the query from. So now we're going to run our retrieval task. And we do this by first choosing an embedding model we want to evaluate. We use this to embed each document chunk, store it into a vector database. And then for each query that we generated, we would embed that query and retrieve the top K document chunks. And if the matching document chunk was in our top K results, that would count as a success. So that's how we get retrieval metrics, like recall K, NDCG, etc. And so you can run this retrieval task for various embedding models. So in our case, we tested it with 4 different embedding models. And we also tested it with the ground truth production queries as well. So with the production queries, like the 2000 that we got before, we labeled them manually. So we found a matching document in the document corpus. So that formed our query document pairs. And then we ran the same retrieval task with our production ground truth queries to kind of use as a proxy for how representative our eval set is. And these are the results that we got. So you can look at the blue bar, which is our ground truth production queries, and the red represents our generated queries. And these are the recall at 10 scores. And we perform this across 4 different embedding models. We use 2 OpenAI models and 1 Gina model, 1 Voyage model. But you can see here that the ranking of our embedding models is consistent regardless of whether you look at the ground truth queries or the generated queries. And you can also see that the scores themselves are also pretty similar, especially when you compare to the naively generated queries here too. So the naively generated queries are the queries that we generated, doing no document filtering. And when we were generating the query, we didn't give it any context or example queries. So the most basic query generation you can do. And you can see here that our naive generation method gave us scores that were significantly higher compared to our ground truth production queries. And this is because when you naively generate a query, you're more likely to generate a query that is, very specific to the document chunk, also in the form of a complete question, which is not very realistic, but it also makes the retrieval task a lot easier, which is why you get these higher scores. But when you're evaluating different models, you don't necessarily want to aim for higher scores. You want scores that are more realistic. So what we're aiming for here are metrics that are more aligned to our ground truth scores. And another interesting finding here was that our generated benchmark resulted in different embedding model rankings when we compared it to MTEB. So these are various embedding models on MTEB English tasks. You can see here that Gina's model outperformed OpenAI's large model. But if you look back at these results here, you can see that OpenAI's large model performed better than Gina. So the rankings are flipped in this case. So this just goes to show that you really need to test on your own data, and you can't always generalize from these MTEB scores. Like if Gina did well on MTEB English, that doesn't necessarily mean that it's also going to do well on your technical documentation. It also doesn't mean that, like OpenAI large is always going to outperform Gina. Like there are definitely cases where Gina would do better than OpenAI large. You just have to see on your own data and experiment. So these are some of the insights that we got from this case study. The original embedding model that they used was text embedding 3 small, which performed worst out of the 4 models that we tested. We also saw the contradiction with the MTEM model rankings that I just discussed. And through our LLM judge chunk filtering step, we were able to identify some irrelevant document chunks in the corpus. So in your retrieval application specifically, there are a few useful like applications of generative benchmarking. Like even if you don't have production data yet, you can use generative benchmarking. Like if you only have a document corpus to work with, you can use that to select the best embedding model for your data and gauge how well your current retrieval system is performing. Identify these potentially irrelevant chunks. You probably want to take a look at it manually just to make sure that it's aligned with your judgment as well. And I went through this before as well, but you can use generative benchmarking to iterate on specific components of your retrieval pipeline. But I think it becomes even more powerful once you actually have production traffic to work with. So if you have queries from production, you can use that for things like query alignment, which is this first point here. So let's say that you have like a set of production queries and you have your eval set of queries, you can cluster your production queries maybe by topic, and you can kind of see like the distribution of topics that your users are asking about. And then you can use that distribution and align your eval set to that so that it matches the distribution of topics that your users are actively asking. And that would just make your eval set even more representative. You can also use this to identify knowledge gaps in your document corpus as well. If you have these incoming queries, you can see what kind of queries might be like out of distribution with your eval set. And that can be an indication that, maybe that kind of topic isn't covered in your document corpus. So yeah, these are all pretty useful applications of generative benchmarking, which you're not really able to get out of just public static benchmarks right now. And just some final notes here. I think the main takeaway from this entire talk is that if you have good performance on public benchmarks like MTEB, that doesn't necessarily guarantee that same performance for your specific use case. And generative benchmarking is a pretty good solution to that. And when we talk about generative benchmarking, that also doesn't mean that this entire process is 100% automated. You do need some human in the loop if you really want a good eval. Like for example, you would want to align your LLM judge. You want to add in like the user provided context and example queries to steer your LLM query generation. So you really just need to like take a look at your data and make sure that this entire process is aligned to how you might judge the data that you're working with. And if you want to read into some more details, we have our full technical report available at research.trychroma.com. You can also try this out for yourself. You can literally just run these two lines in your terminal and try out generative benchmarking on your own data. And yeah, last point here is that Chroma Cloud is now live. You can go sign up, try out Chroma Cloud at this link here. But yeah, I think that pretty much concludes it for my talk. I'm happy to answer any questions now, but thank you everyone for taking the time to join today.
Thank you as well. I heard that there were some new research reports coming out. Are you able to foreshadow or hint at any of the new material, or is that
Yeah.
yeah?
One thing we're working with right now is we're looking into long context versus retrieval. I feel like that's been a pretty big debate for a long time. And when you think about long context, you probably think of benchmarks like needle in the haystack. That's a very popular test that you'll probably see in a lot of like LLM like mono releases. But needle in the haystack is a very easy task for LLMs, and it doesn't necessarily cover like the practical use cases of long context. Like just for some more, I guess, like background here, like needle in the haystack is a very easy task where you're given like a large like corpus of text, and the LLM just has to like pick one like tiny portion of that LLM context. We don't really have any indication of like how it's processing like the entire LLM context. So we're just doing some more robust testing on like various long context tasks of like varying levels of difficulty, seeing which ones actually align with like more like practical use cases and, looking into how like retrieval can help you like overcome those challenges as well. But yeah, it's been something that we've been thinking about for a long time because I think a lot of people are kind of misled by like when people talk about like long context, people just think like, oh, models
Back
just do really
then.
good. I can throw everything into the context, it's gonna do well. But no, that's really not the case. You really need to do some more like robust testing, and we're hoping to um yeah, hope to like show people that.
Lovely. Yeah, I'm really excited for some of this kind of stuff. I feel like I've been making fun of people saying RAG is dead, and they now bear me, and so I gotta step back my statements and explain why RAG is.
Yeah. Coming soon.
Cool. Let's jump into some question and answer. Like, let me know if you want me to take over any of these questions too. I think a lot of the stuff is actually covered in some of the stuff that I'm teaching. Um, I will say one call out for those who are sort of participating in the cohort. Chroma is giving like $1,000 of API credits. So just I think you'll get an email sometime at the end of the week or today or end of the week on how to get access to that. So that should be pretty interesting. I think the first question people have is how do you pick your few shot examples for query generation? Yeah, so I have sort of my thoughts, but I'm curious how you guys did it in your analysis.
Yeah, in our use case, we got to work with production data from weights and biases. So we had like actual user queries. So we would just randomly select around like 5 or 6 from those and then use that as part of the LLM context. But if you don't have any production queries, it's also pretty easy to just manually write them yourself. It doesn't really take a lot. Around like 5 to like 7 example queries is good. If you're building maybe like a RAG like chatbot, you can probably predict like what kind of questions your users are going to ask. They're not going to be like complete questions, most likely like statements or like people are trying to like debug something if you're building like, I don't know, like a technical support bot like weights and biases. So it's pretty easy to like, I guess like kind of predict. But once you start getting production data and you have like a few example queries to work with, then you can start to use those. But regardless, like I think it's pretty easy to like get like a small set of like queries to put into the context. Yeah, what are your thoughts on this?
Yeah, so generally a lot of the work that I've been doing has been working with companies that have like a vertically integrated AI. And
Hmm.
so we just harass our subject matter experts. It's like, okay, what do you actually care about? Like, what are the things that really, are important to you? Like, if you're looking at legal questions, like what kind of search are you doing? And we'll kind of
Yeah.
drive a set of those questions. And the other thing that we do is we'll actually just pass LLMs through all the text chunks that we have, and we'll do some kind of role-playing exercise that says, hey,
Hmm.
you are a paralegal working a case. You've been shown this document. Generate a couple of questions that would have retrieved this document. And then we go back and we harass our lawyers or we harass our subject matter experts and say, is this realistic? Is this something you actually care about? And we kind of do that process. Uh,
Yeah, yeah. I think I've seen that approach a lot too, like kind of asking like an LLM to like play this role. Like if you were this kind of person, like what kind of queries would you ask? But I think, yeah, like you mentioned, it's really important that you actually have people manually review it as well. Like don't just give it to an LLM and trust that the example queries are good. Like, get an expert out the data and make sure they're actually reflective of what your users will ask.
yeah. The latest thing, which I've been testing recently, is actually doing deep research first. So you do the same
Oh,
size, but you do deep research and say, okay, I'm going to build a search system for lawyers that have to deal with
yeah,
insurance claims. Uh,
yeah.
Go do deep research, prepare me this document, and then that's like half of my prompt. Uh,
Oh,
Surprisingly good, right? We did
really? I haven't tried that, but that could be interesting to experiment.
because we did this for like restaurants.
Mm.
And then people were like, oh, we might ask about things like availability and like whether or not there's parking and how you do reservations and can you do like catering. It's like, oh yeah, those are questions people ask, but we only supported like search over the menu. But a chatbot
Mm.
should be able to answer this kind of stuff. And now I'm gonna go build
Yeah.
web crawlers and make sure we do have the
Mm.
information about like parking or like like all this kind of stuff. It's been a really fun
Yeah. That's
test
interesting.
the inventory that we have. Um,
Yeah.
Yeah. Um, I guess a follow-up to this is once you have these queries, can you talk a little bit more about the KPIs or metrics you use to evaluate retrieval here? I think I saw NDCG, but I'm curious to hear more.
Yeah. Oh, oops. Um, yeah, the main metrics we use were, yeah, like you said, like NDCG, but and like recall. We just use these like quantified metrics that you can immediately get from the retrieval task. There are other kinds of metrics that you can get if you use an LLM judge. You can judge for like faithfulness and things like that. But yeah, for this task we just looked at like recall, NDCG, just very basic like metrics that you can use. We didn't use an LLM judge. It's because for like our research, like this was kind of enough to show that our generic queries were like relevant. But I imagine if you're like applying this to your own retrieval application, you can also like add in those more like qualitative judgments as well. Like if you want to test, whether it's like factually correct.
Yeah. Totally makes sense. I also find that, when you're doing these large evaluations, I think in
Hmm.
this example, you had like 8,000 chunks. And like we've seen
Yeah,
situations doing testing over like 10 million documents.
yeah,
Uh, Doing the retrieval takes like 50 milliseconds per test. But if you do an LLM, it's like 1 second per test. And then all
yeah,
of a sudden you wake up, it's like, hey, who ran the evals? We just spent $9,000 on LLM as a judge. Uh,
yeah.
no.
Yeah, it can get very expensive. So I think like, like just having these metrics like recall are honestly like pretty good and they can be like sufficient if you're like just starting out and if you're working with a lot of data as well.
Yeah. Oh, this is a curious question. Um, Anything that you would caution others about when building out evals and observability for any of these tools? Do you, have you or any of your customers felt any like traps when building RAG applications.
Mm, I think it's really easy for a lot of people to like use like automated like evals and they don't
Yep.
really take a look at their data. Like for example, if you are thinking about this like chunk filtering step where you use an LLM judge to like filter out certain documents, I think like a common approach that people might do is they just use, they just like give it a prompt and like trust that it would work. But it's really important that you like iterate in small steps and you actually like look at the data that you're working with. Um, so we initially worked with just like a small set of like 300 document chunks. We
Mhm.
like manually labeled each one and then we will like keep iterating on it, I think like 4 times or something until we got it to like be like pretty aligned and then we extended it to the rest of our corpus. So I think like my recommendation would be to like start small, like don't like scale like way too quickly and like automate everything. Like there's a lot of like manual work that is required in the beginning if you want to do good evals.
Yeah, you can't delegate all the thinking to these LLMs. I would agree in the sense that a lot of it is just a
Hmm.
reluctance to actually like look at the example,
Yes. Yeah.
right? Like there are so many situations where we just like run these evals, like great, like
Hmm.
this like factuality V1 score is 78. Is that good or bad? It's like we don't really know. And then you actually look at the example, it's like, oh, it just seems that like the longer the answer is, the higher the score is. Is that actually what we want? Maybe not. That's one thing.
Yeah.
Also, the second thing too, which aligns really well with what you talked about in terms of the LLM evals, which is I think too many people lean on these LLM evals, which
Hmm.
sort of give you this feeling of control because you're kind of always twiddling with the generation prompt. You're like, maybe if I change the prompt, the answer score will be better. But really, if you find out that your recall is very low, right, you just can't find the document because of some phrasing in the text. Um, if your search is bad, everything else downstream of that is really bad. But I think people feel very empowered to twiddle with the prompt
Hmm.
versus like actually figure out how to make search better. Actually, like think about the embeddings or thinking about what is good precision or having evals there.
Yeah, exactly. You
Like
can't really
those
get
kind of
very
things.
far if you're like only looking at the prompt. And I feel like a lot of that is honestly just like based off of like vibes too, like what kind of like output are you getting? There's really no like I guess like systematic way to do this if you're not, working in these like incremental steps.
Yeah. It's like I think too many people are like, okay, like given an open book textbook, can we get the answers?
Hmm.
Actually, do you even know what page the answer is on?
Yeah.
Right? Like checking that you found page 7 is much
Hmm.
easier than figuring out whether the answer you wrote based on reading this book is straightforward. Um,
Yeah.
let's go with some other interesting questions here. Uh, oh, what was your experience with like the contextual like chunk rewriting? I know you guys maybe
Mm.
did, I think did an article beforehand, but I'm curious, like how did that actually improve search?
Mm, we didn't include it in this specific technical report, but yeah, we have done some experimentation with it before. I guess for some more context, like contextual rewriting is where you rewrite like all of your document chunks so that it's like situated in the context of your document. It was originally some work done by Anthropic, but basically you would do this by like for each document chunk, you would pass that and like the entire document into an LLM and tell it to generate like a summary for it, like
Mhm.
contextualizing it. And then you append that context to the beginning of the chunk. And this is pretty useful because, maybe if you're working with some like financial document or something and you have like a lot of tables, like maybe a chunk you have is like just a table with like a lot of numbers. There's no context into like where that came from or like what any of those numbers mean. If you retrieve that, then that's really not going to be useful to you at all. So context is really important. And we've done some work before experimenting with this and it does help a lot, but I think like a downside of that is that it's also very, very expensive. I mean, you're running an LLM and giving it the entire document for every single document chunk. If you have like tens of thousands of document chunks, it's probably not realistic to do. And when we were actually like looking at our data, we realized like, some of the chunks like don't really need contextual rewriting, whereas like some do, but it's probably not necessary to actually like rewrite every single chunk. And I think like maybe this filtering step could be pretty useful for that. Instead of just like classifying a chunk as like good or bad, maybe you can just have like in this process you can like classify it as like, oh, it just like needs context or like it's just like really poor quality, you can't use it at all, or it's just good. And then if you end up just with like a subset of like document chunks that you contextualize, I think that's a more like cheaper and efficient way to do it. I haven't
Mhm.
tested it out like fully, so I'm not like totally sure what the metrics would look like on that. But yeah, contextual rewriting is useful, but also very expensive. So I would be, um, I think like more intentional about how you use it.
Well, this is the benefit of having like an actual eval harness because I think
Hmm.
the real conversation here isn't, should we use retrieval or should we use contextual retrieval? It is,
Yeah.
okay, well, if we use contextual retrieval, our metrics go up 2%. Is that worth it? Probably not. But if you did contextual retrieval and it went up 20%, then the question is, okay, well, is spending 20 cents per document worth the 20% improvement in
Hmm.
retrieval? That is a
Yeah.
quantified decision that you can make, and you're basically saying, am I willing to pay more for better results? And that's a decision versus like, should I
Yeah.
hang on?
Exactly. I think yeah, like you said, it really depends on your use case. Like I mentioned before, if you're working with like financial documents or like
Exactly.
cases where you're very likely to have document chunks that require context, then yeah, it's probably useful. But you might also have like other cases where um like you don't necessarily need all of that. Like maybe you're working with like 100K like document chunks and like all of them have like sufficient context. It's probably
Yeah.
not necessary. So really just have to test it out and, yeah, like you said, make a decision from there.
Yeah, you'll be surprised. I mean, I worked with a bunch of companies that did transcript processing, and they were using
Hmm.
semantic search, and I was like, I said the words. If I said the words and I heard what they said, like I don't even
Yeah.
need semantic search. Like, what if we just did
Yeah.
that? And it was like 1% less accurate, but 10 times faster. And I was like, well, we might
Oh.
be willing to pay for that because if I want to find
Mhm.
like meeting notes, I want that to be as
Mhm.
fast as possible. But you can
Yeah,
make that
yeah,
decision once you have those evals. But yeah.
exactly.
Um, I think some of these questions are very much the same. I'm curious if anyone has any questions they want to ask live, feel free to like use the hand raise, and I can call you out as I scan the list of questions here. Um, One question I like to ask the speakers is there a question you wish we asked you?
Hmm. Oh, that's a good question. Um, I think something that comes up a lot, I think I like briefly touched on this was like, like if you have like generative benchmarks and like is it just like completely like automated? I just like run like a full notebook. I just like press that one button and everything's like done for me. The answer is like no. Like I think um like manually like looking at our data and um oh, I think there's a question. But yeah, like human involvement is like very critical if you want like really good evals. I think it applies to basically like any case where you're like working with AI as well. I think it's very rare that like your system is going to work well with absolutely like no human in the loop. So that's very important. Like even if you have like generative benchmarks, you still need some like human in the loop to make that process really, really good.
Makes sense. Oh man, I think I'm gonna butcher this name. Srivirang.
Don't worry.
Let me know if I said that wrong, but yeah,
Mm,
shoot.
we're close. So thank you. Great presentation. I just wanted to know how you would be processing metadata into this whole pipeline. Documents a whole lot. Enterprises have a whole bunch of metadata that go along with a lot of. So how would you process that context coming in?
Mm. Yeah, that's a really good question. Um, I think. Oh, I think maybe metadata could be useful, like when you're performing the retrieval task. Like in this case, when we're like evaluating whether like we have like successful recall is just based on like the query document pair. It's either like you succeeded or you didn't. But I imagine if you have metadata, like let's say if you have like a query and retrieve like a category of documents that have like a certain metadata tag, like maybe that can count as like a partial like retrieval success. So maybe it wasn't like completely like 100% match, but it's still like partially relevant and maybe you can count that as like a point 0.5 like score or something like that. I think it can also be useful for when you're doing like chunk filtering as well. Like maybe there are like a few cases, like for example, when we're working with weights and biases here, um, like maybe it would have been helpful if there were like metadata tags indicating like the source that these like document chunks came from. I think that can be like a really good like pre-filtering step before you apply an LM judge. So if like all this data was just like scraped from the website, maybe there was like a case where we have like a metadata tag that says like, oh, this is from like our news section. We'd want to filter those out because that's not really relevant to our users. So yeah, I think like for filtering and like evaluation could be pretty useful. But yeah, Jason, if you have any thoughts on
Mhm.
that, feel free to add.
I think it would also depend on sort of the types of metadata filters, right, that exist. For example, if you have really simple ones like, show me all the news articles from last week, like we can individually test sort of our ability to select date ranges, right? Like, we
Hmm.
had this issue at EXA, funny enough, we talked about this, we'll talk about this today, where I think we were using 3.5. And the way it would search for today made the start time and the end date the same. And so we would search no results. Right?
Oh,
It's like, okay, like today actually kind of needs to be a little bit more future seeking. If it's calendars, it needs to be something else. Let me go add parts of the prompt to test that.
Mhm.
If we had, for example, filters, um, we wouldn't need to search the retrieval, but maybe if I searched for research papers on AI and archive, I need to test whether or not the archive domain name exists in the allowed list of domain names in that search filter. And so there is going to be times where we can verify the retrieval, and there are times where we can verify the structured extraction task, right? Does the search query result in some assertions on the metadata? Is the date range correct? Is the uh, uh, search index filter correct? Is the whitelist domain names correct? Those basically feel like classification tasks that have like 0, 1, pass, fail criteria that we could use to improve our ability to do this search resolution.
Got it. Thank you.
No problem. Jan?
Yeah, hello. I was wondering for the contextualized chunking, if it
hmm
would work, that if you would just summarize the document where the chunk comes from once, and then add that summary to each chunk, and then embed it. That would avoid having to, put the whole text with each chunk. Would that
mm
I think the
work?
danger there is that now we've just replaced one problem with another, which is how good is my summary? Does my summary include all references to named entities? Does my summary obfuscate any numbers? Right? Those become just like a separate set of problems. So yes, we could do that, but now we have to evaluate whether or not our summary is actually good at hydrating the existing chunk. So we've just sort of replaced one problem with another.
Yeah, I think
Well,
also
perhaps,
if you, oh, yeah, I think
yeah,
if you have the same like summary for like every single document chunk, that might make the retrieval task a bit more difficult as well, because then like your chunks become like a lot more similar and it's like harder to like
Mhm.
disambiguate if you have like very similar chunks. I think like if you want maybe like cheaper LLM calls, maybe one solution to that could be to just get like the surrounding text of the chunk. So maybe you don't have to like feed in the entire document into the LLM. Maybe you just get like, I don't know, like 1,000 or like a few like 100 tokens just like surrounding whatever chunk you want to embed and then summarize from that. I think like I've tried that before as well, and I think like that's been pretty effective. Like you get like similar results from like passing in the entire document because usually it just requires like that local context, not the entire document. So I think if you want like a cheaper method, that could be a way. But I think like, yeah, as Jason mentioned, like summaries might bring about like additional problems. Obviously like depends on your use case, but I think good to be aware of that.
yeah, and perhaps this is the first thing to try, and if that doesn't work based on your evals, then you can go to a more expensive way of summarizing. Perhaps that's the takeaway.
Mhm.
Yeah, because I guess for both methods, you know what the price is and you know what the scores are. So you just got to ask ourselves, like, yeah, like, is the extra dollar worth the, 2% drop, etc. George?
Yeah, so I know this is mainly focused on embedding and
Mhm.
vector database, but maybe can either of you speak more to potentially like the trend to going back to more of a search model of which, vector database is just one facet of the entire search picture, and potentially how would evals change with regards to that? Rather than just embedding vector.
Yeah. I would almost say there is no difference. Things like precision, recall, NDCG, these are things that we took from the information retrieval literature. And so actually it's been used to evaluate lexical search for a very, very long time beforehand. And so really, I think the work to be done is actually just making sure that when we do these kinds of tests, that we are verifying whether or not there are significant gains to doing hybrid search or doing just lexical search, right? Like in the example I talked about before with transcripts, it turns out if you're searching over transcripts, because the searcher like remembers the words that was heard and said, and there's never like semantic ambiguity, lexical search does really, really well, right? Because I never need to understand whether or not like I said the word forest, but I searched the word tree. Like that happens in semantic world, but chances are if I said something to you during a call, I remember what I said, and so lexical search does better. That's a discovery we've made because we did this test versus like a assumption that I had over the data. And then the question is now we can ask, great, well, semantic search adds about 500 milliseconds of latency. Is it worth doing hybrid for that additional 500 milliseconds? And maybe we say, okay, for 500 milliseconds, we get a 2% improvement. Is it worth it? Your call, right? Or it could be, for lexical search, it's so much faster, but it's actually, the same performance. Now we can make other decisions.
Yeah, I think like Jason said, I think a lot of like the same principles and just like search apply to semantic search. Like that's where like semantic search like principles came from. So yeah, I don't think like your framework for like thinking about like evals for like semantic search versus search like changes that much. And you can definitely like experiment with like I don't know like hybrid search and see how that like improves performance. But yeah, you really just have to like experiment with your own data and like see how that changes. So yeah.
Yep. Clark?
Yeah, two basic related questions. One was what sort of hyperparameters are you sweeping over, and how long would you spend doing that? And two, what sort of either prompt changes or like I guess just look at your data changes. Do you check various combinations there, and how long do you spend on that? I know you said like messing with your judge prompt, people twiddle. So I was just like curious on your like all the things you checked and how long you spent checking.
Yes. So the first question was like what are the parameters we changed? The second question is how long do we spend doing that?
Yeah.
Okay. Yeah, I think I can go step by step. So for chunk filtering, we basically use this framework called EvalGen where you iterate on like a set of LLM judge criteria. So these are like the kind of like criteria that we would change. Like we had like relevance, like completeness, intent. I think we had like a few others like clarity, like user intent as well. But yeah, basically you would like use these criteria and you would compare like your LLM judgments with your like human labeled like data. And then you can get like an alignment score from there. I think initially you got a score of around like 47% or like something around that range, which is pretty low. And then from that, maybe we can like change like individual criteria because we had alignment scores for like each criteria as well. So if like clarity was like 40% alignment, we probably want to take that out or like modify that prompt. So yeah, you can like change or like either like change the criteria or like take it out or like add a new one. So that's what we're changing. We did a few iterations of this. I think we did around like 4 or 5 iterations. But we did it across like a small subset of data. So we were only working with like 300 like labeled document chunks. So it was like very quick iteration. We weren't doing it over like our entire document corpus. So I think like that probably took like less than a day for me to do. And the LLM calls weren't like super expensive either because you're working with like such a small subset of data. So yeah, and then we also experimented a bit with like query generation as well, like adding in like context and example queries. And yeah, during our process, we would like experiment with like naive query generation as well. Like what if we like don't include the context? What if we don't include the example queries? And we obviously saw that like performance doesn't really like reflect what you would see in production. This didn't really take like that much iteration to do. But again, just working with like a very like small like subset of data, so you can do like very like quick iteration on that. Hope that answers your question, but let me know if I can clarify anything.
Yeah, I mean, so it basically sounds like this whole project got done in 2 days of dealing with the prompt.
Yeah, yeah.
I would also say, most of how much time you spend on it really depends on like what kind of existing infrastructure exists, right? For example, if you have large corpuses that need to be embedded really quickly, it really depends on like, well, do you have your own embedding models and your own GPUs, or do you have to like, harass the OpenAI like embedding endpoint? I think that's one thing where like investments in that really just allows you to run more experiments. And then the other thing I would call out, and from a resource perspective, um, I mostly try to time box how much research we're going to do and then figure out how many experiments we can run. And usually what's going to happen is as you iterate on your prompts and on your models, the marginal improvement in performance will slowly decrease. And you can generally just like visualize that over time. And it's going to be a thing where I think Kelly mentioned like the first experiment went from like 47 to 60, then it goes to 70, then 80, then 90, then 91 and 91.2. And you're like, okay, well, I'm going to stop here. It's been 4 days. And then the real question is, are you investing in your experimental infrastructure to do that really quickly? Like I've joined companies where their embedding models is uh like sequential call to OpenAI. And I was like, well, this is why it's taking you 6 days to do these experiments. Like what's going on? And then their LLM calls are like also synchronous and there's no caching. And so something fails and they got to run it over again. It's like, well, this is why it takes you 2 days to run one experiment. Um, that's a lot of sort of what like at least from a team level, how we think about it. One of the things I really get a benefit from is I just get to use modal a bunch. And so like if I want to run experiments on Wikipedia, it takes me like 10 minutes to re-embed all of Wikipedia with any arbitrary model that I want. And that makes me feel really good about sweeping over a very large set of hyperparameters because I can just pay money to solve that problem. Um, those are the kind of things I really think about, but it is oftentimes more of time boxing like your engineer and then figuring out how to make the most out of the experiments. Um, yeah, maybe like a higher level conversation around that. Because yeah, like you can always get a little bit better if you just spend way more time and way more money, and most of it is actually around setting up the conditions for when you give up the research rather than when you're done. Um, and what's probably going to happen is at some point the retrieval is not going to be the limiting factor, and then you will have earned the right to start thinking about editing the prompt generation prompt. You're like, actually, like I recall is 99%. I know the damn answer is in one of these 75 chunks I put in, but the language model is still not answering the question. Now I really like have the right to experiment with how I answer the question and like how I think about citations and whatnot. But I work with a bunch of companies where they're like filling with a generation prompt and temperature for like 3 weeks. And then we do these evals. You're like, your recall is 40%, man. You can't answer half these questions. Why are you trying to like change temperature? This is the wrong variable to experiment with. Uh, those times that's happened like 3 or 4 times, and yeah, it's kind of silly.
Oh.
But that tends to be what it ends up looking like in real life. George, let's do one more question, and then I think we'll. I'm dying. One more question.
Yeah. So it sounds like almost this is just one part of the larger eval equation, right? Because you're it's almost like unit testing, if you will, versus integration testing, and at some point you do move on to integrated eval in terms of the entire pipeline, from query to response, like how good is the answer, even though your recall might be 99%, but
Yeah.
as you said, your answer is still at 30%. What's wrong? And then
Yeah.
secondly, I'm kind of curious, have you guys experimented with DSPy at all in terms of, doing either performing some of the eval metric and some of the prompt engineering, or in DSPy's case, the lack of prompt engineering, because they treat that as part of eval as well.
Yeah. I'll address like both points. I think the first one about this being kind of like a unit test like within your entire pipeline, I think that's a really good way to think about it. I think like as Jason mentioned, like if you have like this full like RAG pipeline, but you're like only looking at the generation part, you can't really pinpoint like whether, like exactly where your system is failing. So you mess with things like temperature, but like maybe the real problem is like in retrieval. And this is like how you would test for that individual step. And so you can like really pinpoint like, okay, it's like my retrieval failing is my generation failing, and then you can kind of work more like systematically from there. Um, so yeah, it's just like one part of like the entire like eval process. And regarding DSPy, we didn't experiment with that in our research, but I think that could be really interesting to work with. I guess for more context, like DSPy is kind of a way to like programmatically like optimize like LLM prompts instead of just like, manually like writing it out like each time. I haven't worked with it too much myself, but yeah, I think that could also be pretty interesting. And um yeah, if like anyone like applies it to this.
I'll say on the DSPy side before
Yeah.
you jump off, which is it's really good if you have all the answers, then you can actually optimize something. But
Mm,
that ends up requiring more work because what I've actually said is actually I have a label for every pair that I've created, and most people that I work with don't have those labels. Um,
mm,
and so I think with mostly the optimization stuff, it's like, yeah, if you give me a CSV file of all the answers, the chunks, and the right answers, and whether or not they're good, I can do something in 20 minutes. But it turns out 90% of the work was producing that CSV file. And then by that point, you may as well just like own your prompt generation code as well. And so the work to get to a point where you got to use DSPY is usually way, way greater. And then incrementally, um, in terms of like owning your execution, like your orchestration and your execution, um, it like the prompts end up being quite simple. And when something needs to change, oftentimes they're changed in ways that don't have scores attached to them, right? Like we don't actually have good answer, bad answer labels. It's actually a bunch of really nuanced things like how are you using citations and, you know, is the answer like a sufficient length and are we being ambiguous with like referencing things in the context? Uh, those things DSPY can't do, and it's really just about understanding your customer preferences.
mm.
Um, with that said, I think we can end it like 4 minutes early because I need to get some water, and then we're gonna jump off to the next lecture that is happening today, which is doing semantic search over the web with Exa. Bing is shutting off their search API. A lot of companies are need this kind of stuff, and I think Exa is in a really good position to share more about how they do like internet scale search. And with that, Kelly, thank you so much. I actually learned quite a bit from this talk, and I'm excited to see you guys in San Francisco. Awesome.
Yeah. Thank you so much for having me.
Awesome. Take care.
All right.
Thanks, everyone.
Bye.